Today's lesson will be recorded. If you are not comfortable speaking and having your voice recorded, please send me a chat and communicate with me in that manner. I don't want anyone to be recorded against their will. So I just want to let you know that today's session is being recorded. Today we are going to talk about acceleration due to gravity. So we're doing the same thing as last time essentially, but now we're in the Y direction. We're going vertically. So we are going to be dropping and throwing up things. Things are going to be moving vertically. And we are always in a free fall state. And free fall means it's falling with only the effects of gravity. And gravity, the acceleration G, the acceleration due to gravity, we talked about this a little bit in a previous chapter when we compared something to the acceleration due to gravity. G is equal to negative 9.8 meters per second squared. So the gravity always pulls downward. That's why this is a negative number. So objects are always accelerating downward. On the way up, they're slowing down, right? On the way up, if I come over here, the spacing is going to get less and less between the objects as it goes to, the object's going to change size as it goes up, and on the way down, the spacing becomes greater as it falls because this one's speeding down up, this one's slowing down. And they all accelerate at the same rate. And we're just going to use 9.8, negative 9.8. It goes out to more decimal places, but for our intents and purposes, negative 9.8 will be fine. These problems are also kinematic equation problems in the Y direction. And we're going to be going through some problems today. One interesting thing is if you throw an object up and then it comes back down, right? This is its position versus time. As it goes up and comes back down, at the very top of the thing, it still has an acceleration downward, even though at this point its velocity is 0. Remember, acceleration is the change in velocity. So you have to have two velocities. So if your velocity is 0, you can still be accelerating. So just a fun little fact for you. In the Y direction, we have these variables, Y naught, Y, V naught, V, G, and T. And G is always negative 9.8 meters per second squared. Our equations change. V equals V naught plus GT. Y minus Y naught equals V naught T plus 1/2 GT squared. Y minus Y naught equals 1/2 V naught plus VT, and V squared equals V naught squared plus 2G Y minus Y naught. And that is the background for this section. We are just going to be solving problems again, but instead of the X, the horizontal will be using this Y information. And they're done the same exact way. We read the problem, we reread the problem, we shove in the variables, knowns and unknowns, then we do the algebra and solve, and then check to make sure our answer makes sense. So today we are on page 92 in the textbook. So get your textbook out. Hopefully you have that formula sheet out like I encouraged you to do last time. And we are going to start with problem number 44. Page 92, it's probably page 113. In the online book, on the PDF. All right, so number 44, this is the first one we're going to do. We're on page 92. Number 44. We know it's a Y formula, or a Y, just because. Now, this is going to be one of the tricky things on the test, is knowing if it's X or Y, but vertical and horizontal. We know this one's Y because that's what lesson we're in. A rescue helicopter is hovering over a person whose boat has sunk. One of the rescuers throws a life preserver straight down to the victim with an initial velocity of 1.40 meters per second and observes that it takes 1.8 seconds to reach the water. List the knowns in the problem. We're going to do that anyway. How high above the water was the preserver released? So that's essentially what we're trying to find here. Let's reread it and pull out our variables. A rescue helicopter is hovering over a person whose boat has sunk. One of the rescuers throws a life preserver straight down to the victim with an initial velocity of 1.4 meters per second. So this is our initial velocity. Now, it's being thrown downward. So this is negative 1.40 meters per second. That's important. It's going downward, so it has to have a negative sign. It takes 1.8 seconds to reach the ground or reach the water. The acceleration is negative 9.8 meters per second squared. Now, one of the common mistakes that students make is they say the final velocity is 0 because it hits the water. This is not how we analyze the situation. We have the water, and we have our life preserver, and our life preserver is going down towards the water. The initial velocity is up here. The final velocity is the instant before it hits the water. This is the velocity that it actually hits the water with. So when you're solving for this velocity, you're not solving it after it hits the water. This is the velocity when it reaches the water that it has. So that's one thing that you want to get used to. Because a lot of times you're like, oh, it hit the water. It's got to have 0 velocity. But that's not how we look at this problem. Our goal is to find out the height that it was released from. Why not? We do know that the final position is 0. The water level is our reference level, and this should be a question mark at why not. That's what we're looking for, not a 0. The reference level is the water. That's our 0 position. We're looking for the height above the water that it was thrown down with. So we have to pick out an equation that does not have v in it that allows us to solve for y. Y minus y naught equals v naught t plus 1/2 gt squared. 0 minus y naught equals negative 1.4 times 1.8 plus 1/2 times negative 9.8 times 1.8 squared. Negative y naught equals negative 18.40 meters. Y naught equals 18.40 meters. That's the initial height that it was thrown down at. Does anyone have anything they need clarified there? I'll look on the chat. Nobody sent me any messages. Did I go too fast or anything? Pretty good feedback I'm getting here. Let us go and try another problem. We got about 4 to get through today. Let's shut this down. All right, next problem. Number 50. I want you guys to do part A. Take the variables, find the formula, solve part A. We're going to spend time working at our seats today because it's good for you. So do part A at your seats. The initial position is 0. It's on the ground. The Final position is 2.5 meters. The initial velocity, we don't know. At the top of the jump, what's the velocity at the top? 0. It's always 0 at the top. Gravity is negative 9.8 meters per second squared. And we're looking for in part A, V naught, and in part B, T. Our goal is to find V naught. So the only equation we have that doesn't have T in it is V squared equals V naught squared plus 2G Y minus Y naught. Our goal is V naught squared, so we take it to the other side, negative V naught squared, because this is 0, equals 2 times negative 9.8 times 2.5 minus 0. V naught squared equals negative times a negative. So negative 2 times negative 9.8 times 2.5. V naught equals 7 meters per second. All right, so those of you who didn't get 7, do you see what you did wrong? Do you have any questions? You can ask them, you can chat them, whatever you want to do here. Oh, I see you. Thanks, Adam. You could have sent that privately probably, but you let's put that out there for us. Anybody have any questions on that? Now, in part B, it's saying, how long is the kangaroo in the air? So what I'm going to do is I'm going to erase this because I don't have any room left. And I'm going to write in my initial velocity. We found that, and we're going to solve part B. So I come here, I'm still on the eraser. And now our goal is to find the time. Well, as he goes up, the kangaroo, maybe it's a girl kangaroo, and then comes back down, the time up equals the time down. So the total time, T total, is going to be 2T. So what we're going to do is, since we know the velocity at the top is 0, we can find the time up. So we're going to use these variables and find the time for one way of the trip and then multiply it by 2. Let's take a look at how to do that. We'll just use the easy formula. V equals V naught plus GT. T equals V minus V naught over G. T equals 0 minus 7 over 9.8. Negative 9.8, sorry. .71, that's not right. Yeah, 0.71 meters per second, or excuse me, seconds. So the total time is 1.42 seconds. That's how long the kangaroo's in the air. Anybody have any questions on that?
So why do we times it by 2?
Because the time up is equal to the time down. So the total time in the air is the time up plus the time down. Like if you throw a ball up, it takes 2 seconds to get to the top, and then it's going to take 2 seconds to get down again. So it's 4 seconds total. If we did it mathematically, the other way we could do it is for the whole trip, right? We know if I erase this, one of the rules of free fall tells us that the initial velocity on the way up, whatever it leaves your hand, is the same velocity it returns to your hand at. So we know that this final velocity for the whole trip, so if we did this for the whole trip, the final velocity would be -7 meters per second. So we could do that again. V equals V naught plus GT. V minus V naught equals GT. -7 minus 7 over -9.8 equals T. And that's going to become 1.422 or whatever we had there. 1.43, it rounds up a little bit, same idea. So you can solve that either way based on what data you're using. But since everything is being accelerated at the same rate, whether gravity or by gravity, whether on the way up or the way down, you're going to have the same time interval, and the velocity it leaves your hand is the same it returns at, because it slows down just as fast as it speeds up. Anybody else have a question? Hopefully that answered your question. All right.
Yes, thank you.
Oh, I thought so. I'm glad it worked, helped you. Let's try another one. Well, the next two are kind of complicated. We'll do 46 together. 46 together. I'm going to change up colors. I'm tired of looking at red, burning my eyeballs. So 46, I'm going to read this before I write down my variables. It says a swimmer bounces straight up from a diving board and falls feet first into a pool. She starts with a velocity of 4 meters per second, and her takeoff point is 1.8 meters above the pool. How long are her feet in the air? What is her highest point above the board? What is her velocity when her feet hit the water? So essentially it starts like this. She's on the diving board. She jumps up and lands down here in the water like this. So the distance between the water and the diving board, 1.8 meters. She starts it, her initial velocity right here, V naught, is 4 meters per second. So that's really all the information we know, is that she starts at 4 meters per second and she's 1.8 meters above. We don't know the velocity she hits the water with. We don't know the time. So if we write down our variables, write down my variables, V naught, V, G, Y naught, Y, and T. So V naught is 4 meters per second. V we don't know. G is -9.8 meters per second squared. Y naught is 1.8. Its final height is 0. That's in the water, and we don't know the time. Now the question asks, how long are her feet in the air? Now if we solve for T right away, we could use a quadratic formula. I don't really feel like doing that. So let's go to part C and solve part C first, which says, what is the velocity when her feet hit the water? So the first thing I'm going to find is V. I know V naught, I know G and Y naught, so I can use this formula. V squared equals V naught squared plus 2G Y minus Y naught. V squared equals 4 squared plus 2 times -9.8 times 0 minus 1.8. V equals 7.16 meters per second. That's the velocity when she hits the water. So it doesn't matter that she goes up first. That's irrelevant. because gravity is accelerating you the same way. It doesn't matter if it's slowing you down or speeding you up. Gravity has the same effect on you. So this is just an interesting look at that. You can find this velocity without worrying about the upward motion. Then in part B, it says, what's the time? So for part B, we know that V, we found V to be 7.16 meters per second. Now our goal in part B is to find the time. So again, we can use our easy formula instead of using the quadratic, which is just not much fun. Oh, now notice when you look at this, 7.16 minus 4 over 9.8. Is her final velocity actually 7.16? This is the magnitude of her velocity. Her velocity is in the downward direction. That means that this is negative 7.16. Notice if I would have done this, I would have gotten a negative time. That's a good key that you did something wrong. So it's negative 71.6 because it's downward. So 11.39 is how long she's in the air, 11.39 seconds. That's not right. 1.14 seconds. Sorry. I was like, wow, that's a long time to be in the air. 1.14 seconds. This is tricky. This idea that you have to make this negative. The reason it doesn't work out is because that other formula was v squared equals v naught squared. So in this case, you're only finding the magnitude. You have to remember that the velocity is downward. And when you get a negative time, you know that you did something wrong. So maybe that'll be your key to remember that. So that's kind of tricky. Are there any questions on that? Either verbal or in the chat? Let me check with the chat.
Do you have to multiply the time by 2 in this case?
No, that was strictly just in that one scenario because it was going up and down. This is the time from when we leave to when we return. So you can see our initial velocity was here and our final velocity was here and the time was the whole trip. Does that make sense?
Yeah.
All right, the other one, it just said how high are we jumping? So there wasn't a real distinct time of start and stop or velocity to start and stop with. And then in part C, they changed directions a little and says, what's our highest point above the board? So for part C, we have to get a whole new set of variables, but we got to remember our original ones. So in part C, they're asking you for this. Y. How high above the board? So that makes y naught equal to 0. We're looking for the height above the board. So it's kind of tricky. So v naught is still 4. V at the very top is not 7.6. V at the very top, and I wish I could ask you this in real life, but I can't. V at the very top is 0. Remember, V at the max is always 0. The initial height now changes from 1.8. Oops, that's not the eraser. 1.8 to 0. And Y is what we're looking for. And we have all the variables but T again. So if we have all the variables but T, we can use this equation. G. I definitely ran out of room there. So we know V is 0. We're looking for Y. So negative V naught squared equals 2G Y minus Y naught. We'll divide both sides by 2G. Negative V naught squared over 2G equals Y, because that's also 0. So Y equals negative 4 squared over 2 times negative 9.8. Y equals 0.82 meters. All right, let's pause and I'll go over A and show you that so that you can see if you're on the right track. That way I'll give you confidence. So it says a steel ball is dropped on a hard floor from a height of 1.5 meters. I'm going to go with a different color. And rebounds to a height of 1.45 meters. Calculate the velocity just before it strikes the floor. So this is on the way down. So Y naught, Y, V naught, V, G, and T. V naught is 0. It's being dropped. So its initial velocity is 0. It falls 1.5 meters. So its initial height is 1.50 meters. The floor height is 0. We know it's negative 9.8 meters per second squared is gravity, and our goal is to find V. V squared equals V naught squared plus 2G Y minus Y naught. V squared equals 0 plus 2 times negative 9.8 times 1.5. V equals, or negative 1.5, sorry, 0 minus 1.5. 29.4, oh, I got to square root that. 5.42 meters per second. That's the velocity it strikes the floor with. And I'll go through and show you how it's been a lot. Fine, I could have left that formula up there, I think, but whatever. I'll erase all this. We got a new set of variables because we're going in a different direction. I'll leave the 9.8 up because that's staying the same. So in part B, we'll go with a different color, green. We're going up. So our initial height is 0. We're on the ground. We're going up 1.45 meters. We're looking for our initial velocity, and our final velocity is 0. So in this case, we are looking for our initial velocity. V squared equals V naught squared plus 2G Y minus Y naught. This is 0. This is 0. So negative V naught squared equals 2 times negative 9.8 times 1.45. V naught equals oh, that's not right. Can't type in my calculator all of a sudden. 5.33 meters per second. I'm hoping that's less than the other one was. I'm sure it is, not much. And then part C talks about the acceleration while it's on the ground. It's losing the velocity, but we're not going to do that. That's just a little